Hello everybody, my name is Kenan Zenolov. Today I will be presenting my physics 101 final project where I'm measuring the spring constant by Hooke's law and calculation of the friction. I'm a final year CA student. So in this experiment, I recorded a short video about what I have done, but it doesn't show the full reality because I didn't have any friends in the laboratory. I just asked someone to do an initial demo that what I'm gonna do. As you can see in the video that I'm using a couple of masses to check how we will through actual the masses by the real hook and thread. So in this experiment, I focused on two main goals. And the first one was measuring the spring constant using the Hooke's law. And the second one was the calculating the friction force acting on an object sliding on an inclined plane. So initially the idea was to release the object from different heights and measure the spring's compression. But unfortunately, due to difficulties of the bouncing and the friction of the when, as you can see in the video that I showed, bouncing of the and friction of the that table, I modified it a bit. So initially, therefore, instead I compress the spring first, and I then let it release, and then I measured the resulting the motion. The key principle here was to apply the conservation of energy rule and to see how it works. And in the second part of the uh, objective, I tried to see how the Hooke's law describes the real spring's behavior. And therefore, I attached three different masses to the spring. And in the video, you can see that I tried a couple of them and 4 or 5 of them. And in the report, it's written that what I did. Actually, so I attached these different masses to the spring and measured how it stretched. Then using the formula I provided in the report, I calculated the spring constant for each case. And in the second part of my experiment, I set up an inclined plane with a spring fixed at the bottom, and I compressed the spring at different amounts in 1.5 centimeters, 3 centimeters, 4.5 until the 7.5. And I released the object and measured the maximum height to see how it reacts. And by using the conservation of energy and work energy principles, I calculate the friction force. And actually, in the third part of the project, where I calculate the data, in the measurements, I saw that the average spring constant I calculated was around 307.2 newtons, and which had 4.5 error percent compared to the ideal value of the real calculations. And for the inclined plane experiment, I recorded different compression amounts, initial heights, maximum heights, and friction distances. And using these values, I calculated friction done by the work. And the average coefficient of the friction I found was about 0.18. And I graphed all of these plots in the report very clearly. That's visible, as you can check. And finally, I plotted all of these graphs, show the force versus elongation which follow the straight line, which supported Hooke's law. And then I plotted work done by friction, which also varied quadratically with spring compression as expected. So overall, by this experiment, I tried to see how Hooke's law reacts to the real experiments, and we saw that Hooke's law gives a good but not perfect model for real springs, and energy conservation can effectively be used to estimate the friction forces. Thank you for listening.